State what is meant by a field line of force in an electric field. So a field line in an electric field shows that the direction a positive charged particle will take in this electric field. So the field line is just telling you about the path or the trajectory in which a free positive charge will move. Now, an electric field has two different regions, X and Y. The field strength in X is less than that in Y. Describe the difference in the pattern of the field lines in X and in Y. So, in Y, the field is strong. Now, the field lines showing a stronger field means that the field lines would be closer together, and a weak field is shown by field lines being separated from each other. So the difference in the pattern would be that in Y, the field lines will be closer, while in X, they would be further apart. Closer signifying stronger electric field, further signifying a weaker electric field. Now, a particle has a mass of 0.15 U and a charge of minus 1 e, where e is the elementary charge. Particle P and an alpha particle are in the same uniform electric field. Calculate the ratio of the magnitude of acceleration of particle P to the magnitude of acceleration of particle alpha. So we know that the acceleration can be determined by saying that the net force, which is the electric force, which is Q times E, is equal to mass times the acceleration of the particle. This gives you acceleration as QE over the mass. Now we want to find the ratio of these accelerations. So that would be for a particle P, this would be charge on particle P, a mass of particle P, and they're in the same uniform electric field, so E is the same. And the acceleration for particle alpha is charge of particle alpha times E over mass of particle alpha. So the ratio of AP to A alpha is EE would cancel out, right? And you would get QP over MP times M alpha over Q alpha. Now, for particle P, you have these values. Mass is, so this would be charge is minus 1e and the mass is 0.15 u. For alpha particle, it's given in the data booklet, or you should know it's 4 times u divided by the charge on alpha particle is plus 2e. So EE cancels, UU cancels, and this gives you a ratio of 13. So you get minus 13, right? But they want the magnitude. So you just take the absolute of these things. So you get 13 as the ratio. Now, particle P is a hadron composed of only 2 quarks. One of them is a down quark. So there are 2 quarks in particle P, and one of them is a down quark. What is the other one? By considering charge, determine a possible type or flavor of the other quark. So what flavor is the other quark? By considering the charge on particle P. The charge on particle P is minus 1e, right? So the charge on particle P is minus 1e. So, and we know that the charge of a down quark is what? It's minus 1 by 3 e. So, what do I add to this minus 1 by 3 e plus another charge of the quark that is unknown, and the total charge I get is minus 1e. So what the value I get for this Q, this one is minus 2 by 3 e. Minus 2 by 3 e corresponds to an anti-up quark. Anti-up quark.